Hey there. So in this video, I'm going to be talking about an app that I just created using something called Streamlit, which helps the app creation process. So in this app, in this video, I'm going to show an app which is going to help you predict customer churn. Now, customer churn prediction is something that's sort of super important in the context of marketing and marketing analytics in particular. And you can do it in so many ways. There are so many algorithms. There's so many approaches. So I'm going to talk about the algorithm and some other mathematical concepts that are involved in it a little bit later in the video. But let's actually talk about the data set. So how we're going to carry out this prediction. So this prediction is going to be on the basis of a customer survey. The data that I'm actually going to show you is dummy data, but I've actually used it for real data, and this approach has worked well. So the customer data is based on a user survey. The customers who have already made purchases, they have been asked a set of questions, and those have been recorded. Some of the answers are numerical, some are non-numerical, or rather they're categorical variables. And based on that, you can use the data and the information that you've gleaned from it, the analysis from it, and then make predictions on new users for those same data points, having information for those same data points. So let's actually dive into the data set and show you what's the stuff that I'm talking about. So these are the columns here. These are the variables that we're going to use. As you can see, this is what is called a label data set, meaning that for each of these users, which I think is about 1,000 users here, you have the labeling of the target variable. So the target variable means the thing that we are going to try and predict. So success simply means whether or not we have been able to you have been able to retain this customer, say within a certain date range certain period. So if it's yes, it means that they have been retained. If it's no, then it means that they have churned. So that's why this is such a useful, important variable. This is basically the target variable. This is what you're going to predict whether success is going to be yes or no. Now, this type of prediction, this is basically a classification problem where you are essentially trying to, uh, you know, predict on the basis of a binary classification. So the answer is always going to be either in yes or no. That's pretty much it. And let's look at the variables. It's brand recall. How much are they able to generally recall the brand? And the question, of course, was a little bit more detailed in the survey, and it varies from say low, medium, and high. Then there is, let's actually look at some of the categorical variables first. So brand recall is one, non-numerical values, as you can see. Then there is app usability, satisfaction. Then there is price satisfaction. Then there is marketing awareness and age group and willingness to recommend. So whether or not, or how much rather, they are willing to recommend the brand to others. Then there are some numerical variables as well, like product variety satisfaction, accessibility support, customer support, competitor satisfaction ratings, so just to understand how favorably they actually view the competitors of this particular brand. Then there is the last purchase value, so that's like the actual conversion value of the last transaction they have made. Those are the numerical ones. So this is the data set, and as you can see, we're going to try and predict whether or not it is successful initiative to retain them or they have churned. Now, I'm actually going to walk through quickly the application process itself. It's most of the background work has already been done in preparing a code. So I'll walk you through the code first. So you'll see that this section here called app.py is this basically is a Python code here, and there are several sections within it. First, we import a lot of libraries. sklearn is a very important library which is used for any kind of statistical analysis, very common. And then you have the actual Streamlit code for running in this particular environment. And now we actually get into the machine learning model. So this model that's getting fed the data from the data set, the X column, the Y column, then the training and testing. So these are all part of machine learning processes. So I'm not going to get into that, but I'm going to just give you a quick overview of what this model is, because this model is the backbone of this analysis. Okay, so like I showed in the data set, this is the binary classification, right? So the binary classification requires a certain kind of approach in machine learning. If it was, say, a regression problem, then you could have used any other linear regression or multivariate regression or something like that. But this is basically the algorithm called KNN, and the full form is K nearest neighbors. Okay, so as you can understand that this basically involves uh, trying to find out some nearest neighbors around a particular data point, and then seeing whether or not what exactly is the category of those neighbors. Based on that, the category is assigned to that particular data point. So this is basically from Free Code Camp. It's a very good website, very well known, and it has a lot of data science algorithm, content on those algorithms. So let's quickly look at this simple example here. So first, consider this diagram where you have red points and blue points, and then a new point is introduced. This is green. Now I have to try and classify whether it's red or green, right? Now you choose randomly a value for k. Okay, this is the tricky part. You have to choose a value for k. There's similar other algorithms as well. This k means clustering, which kind of has a similar approach where you have to give a value for this k at the start. And so suppose you have chosen k as 3, so you have chosen 3 neighbors here, as you can see, 2 red and 1 blue point. And since most of them are the majority classes is red, so the new entry will be classified as red. As you can see, this has now been made red. So that's pretty much the crux of the algorithm. It's very simple in its in its concept. Now the point is that there was one crucial thing that was done here, and that was to choose which were the points which were the closest, right? How do you decide whether a point is the closest or how close a point is? You obviously have to measure some sort of distance, right? Now measuring a distance between 2 points can be done in numerous ways. Well, not numerous, but at least several ways. And couple of common ways here that are listed here. For instance, the Manhattan distance and the Minkowski distance. So there are some formula, how these are done, and this is one distance. For instance, form distance formula. I mean, you take the square root and then the sum of squares of the differences between the points. So that is one way of calculating a distance, and there are several other formula. But yeah, just wanted to, I'm not going to talk about the formula in this particular video. That's not the objective here. Just wanted to make you familiar with the idea. And as you can see here, this is another document where I've tried to show, how the KNN algorithm basically, has been reproduced through code. That's how it's getting implemented in Streamlit. And several versions of this were done because we had to, I had to rather try and carry out several iterations before it probably worked. So yeah, I mean, so this is what is going on. You're basically training and testing and making the algorithm ready for functionality, and then you also calculate something called the performance metrics. So how well is the model actually doing? Whether or not the model was the right choice for making this kind of a prediction. That is basically done through several metrics. So these metrics are called performance metrics, and yeah. So there you go. F1 score, accuracy, precision, recall, and AUC. These are some of the important metrics that are required to be calculated in order to understand whether or not the model is a good choice. And then there is some plotting that is going on, and yeah, pretty much the rest of the stuff is for generating the app. Now let us actually try and run the app here. There's some code here. I'm again not going to walk you through every line of the code, but I'm just going to give you an idea. So this environment is called Google Colab. I've introduced it several times in my previous videos as well. This is completely free to use, and it runs on the cloud. So pretty good for those who are not looking to really trouble the system too much. And then this is where you get the IPv4 IP address. And once you have that, and this code is ready here in this particular file, you are going to be able to get sort of a app link, and this app link is where you're going to have to click. You're going to have to grab this particular code here. Okay, this is giving you some sort of error right now. Show you once more. You will have to run it. And once you have this URL, it's going to generate a URL for the app. Basically, it's getting hosted. I'm going to have to sometimes do some pushing because, as you can understand, it's running online. And this app is, I think, ready to run now. So as you can see here, KNN prediction with permutation-based feature importance. So one thing that I forgot to mention at the start is what it's going to do. So apart from doing the prediction, it's also going to give you information on the data point. So these different columns here, these different variables, these are called also features in, again, machine learning parlance. But which of these features are more important, to understand, or to, in the entire process of predicting success, meaning, whether or not the customer is going to be churning or not. So in that determination, which of these are more important, that process is called, calculation of feature importance. And this again can be done several ways. Okay, you can use something called SHAP values. You can use permutation-based methods. So, I'm again not going into that, but something that I can do in the near future. So this is where I upload the data, and as you can see, this is the same data that I have here, table copy. This data here, shows some of the um, data points. So basically, top 5 data points, and then you can click on this button called Run KNN algorithm, and then it's going to start giving you the probability of success, and probability of success being yes and probability of success being no. So as you can see here, 68% success chances. So you're going to retain. There's a high probability that the customer is going to be retained based on the data set. Okay, so now these are the performance metrics that I was talking about, and I showed the parts of the code where it was getting calculated. So this basically gives you an idea how good the model is. So there are different ways of understanding the outcome, or how good the model is. But obviously, one better way to understand it is the F1 score and the accuracy. And the accuracy, as you can see here, 63%, which is decent, and the F1 score is sort of the overall explainability of the model in understanding or determining the target variable that we're concerned with, which was success in this data set, which is 75%, which is also pretty decent. And these are the feature importances that I was just talking about. So feature importance simply means that which of the points are actually important, which of the data points, which of the variables are most important in determining the outcome, the target variable. As you can see, this gives the feature importance, and it breaks it down to their individual values, by the way. So so if it's, suppose, marketing awareness here, and marketing awareness is has got 3 values, which obviously gets which they get which keep getting repeated over the different data points. And so each of they have been reported here separately. So some of these have negative values that really not really supposed to be there, but doesn't really matter. This is a dummy data set, and everything has supposedly should have some sort of positive value, even if it's very low. But negative simply means that it has not has a very poor impact on the overall calculation of or the determination of the outcome. But that's in a real sort of situation, you will probably not come across that sort of a thing, but it doesn't really matter. What I just wanted you to show is how the app really operates, and then you can actually have a custom prediction. So what you already had here was the prediction, the mean probability of success from the results that you got from the from running the algorithm. But this is also custom prediction. So suppose you were to give specific data points. So like you see here, if you want to select a value for brand recall, and you can choose a value, you can choose different values here. And once you input these values, you can get a specific outcome for those specific input values for each of the feature points. Each of the features or data points, and then it's going to give you the probability, the predicted probability of success again. So you can change it to anything like, say, low, and then it's going to, as you can see, it started doing this thing called running, and meaning that it's recalculating, and then it's going to give you a new probability of success, and you can see the outcome here. So you can see the probability of outcome, the probability of success, the specific value of the outcome that has changed here. So this is how it works. It's a pretty cool app. As you can see, it's all done for you, and you can upload the data set, predict the results, and get the performance metrics, and also get feature importance table and a custom prediction. So this is the app that I was talking about. It's taken a while to get this running, and I've made videos on Streamlit previously as well. If you need any more information on this, just get in touch with me or drop in the comment section. And if you also want to know a bit more about the algorithm or what are the other alternatives. So when it comes to these kinds of things like say prediction and stuff like that, it's always important to keep in mind that there's no one method. There are multiple methods that can be there, and that is precisely why the performance metrics are so important. It's not just it's just not just looking about it's not just looking at the probability of success being yes or no. You really have to look at the performance metrics, okay? And performance metrics give you an indication whether or not you have chosen the right model. So the KNN model here obviously is one choice, but there are other choices that could have been there. There's random forest, there's decision tree, and a whole lot of other stuff that you can use. Logistic regression. There are so many models that can be used for binary classification. So yeah, this was the overall video. If you want more information, like I said, you can always get in touch with me or just mention it in the comments, and I'll get back to you with as much help as I can provide. And that's pretty much it. Thanks for watching, and I'll catch you in the next video.